we are going to see the z-test through two examples in different situations. First one, we're going to see here, bags of salted cashew nuts states that their net contents is 100 grams. The manufacturer knows that the standard deviation of the population is 1.6. So this information tells us that the population standard deviation is 1.6. So the population standard deviation is known. So that's why we're going to use a z-test. A customer claims that the bags have been lighter in recent purchases. So the factory quality control manager decides to investigate. The fact that they say that's lighter, so they less than 100 grams, this is going to tell us about the alternative hypothesis. He samples 40 bags and finds that their mean weight is 99.4 grams. Perform a hypothesis test at the 5% significance level to determine whether the customer's claim is valid. First thing is to state null and alternative hypothesis. In this case, the null hypothesis is that the mean is 100. The alternative is that it's less than 100. This is a one-tailed test. Then, after this, we're going to need to insert some information in the calculator. The samples 40 bags, so the sample size is 40. We have already seen that the population standard deviation is 1.6, and the sample mean is 99.4. So we go to the calculator to find the p-value. So we go to the calculator, then we go to statistics, and then we go to tests, and then we go to z-test. We don't have the information in the calculator in this case. We go to statistics, and then we put the information from the problem, 100 for the mean, that is being claimed to not to be 100. Then 1.6, the standard deviation. The mean was 99.4. So we put 99.4. And the sample size 40. The value of mu, the alternative hypothesis is that it's less than 100. So that's why we choose this option. And then we just calculate. And then when we do calculate, we get the p-value. The p-value in this case is 0.0085. So p-value is 0.00885 to 3 significant figures. This value is smaller than the significance level 0.005. So since this is smaller than the significance level, so we reject the null hypothesis. So if we are rejecting the null hypothesis, the mean is not 100, it's less than 100, then the customer's claim is valid in this case. But could be a different situation where rather than having just the data here, the mean and the sample size, we could have the information, the very similar situation. But in this case, we actually have the data. So what would change? What would change is that now we use the calculator to put this information in the calculator, in the list. The hypotheses, of course, are the same. The only thing that changes in this case is rather than being 40 bags, it's 10 bags, and then the 10 values are here. So then we would have to go to lists to put this in the calculator. So I'm going to repeat here the same hypothesis, and then go to the Texas calculator to put this information. So we go to statistics, and then we go to edit. I've already inserted the information here. Then after that, we go to statistics, tests, and then this time when choosing z-test, rather than choosing statistics, we go to data. Then the calculator is going to get the information from list one. So we just put 100 and the population standard deviation. The same hypothesis, so we just calculate, in this case, 0.00330. So p-value 0.00330. 0.330. Again, this is less than 5%. Again, we would reject the null hypothesis and then say that customer's claim is valid. The same calculations could have been done in Casio calculator. The first one, we would go to the calculator and then choose in menu statistics, we would go to the lists. Suppose we don't have the information in the lists at first about the first problem. If we're solving the first problem, we go to tests, choose z-test, and then one sample, and then we would choose var, because now we are inserting information. The hypothesis less than mu0, the mu0 is 100, sigma 1.6, the mean in this case 99.4. It's the sample mean. The sample size 40. Then we are all ready. So the same value, we got the same value, but in this case, the calculator gives in standard form 0.00885. So we got the same result. And then for the second problem in the calculator, then we would change here to test, z-test, one sample, but then we would use list. And then by using list, the calculator is going to get the information from the list that's here with all the 10 values. And then we follow the same process. Choose this. The calculator is going to get the information from list one. Then we just execute, and then the p-value is here, the same p-value that we found using Texas. Considering now the critical values, the critical region, which is another way of deciding on whether to reject or to accept the null hypothesis, we need a value called the critical value. In this case, it's a 5% level of significance on a z-test. So we use the z distribution, the standard normal distribution, mean zeros and deviation 1, to find the value that is that has an area of 0.005. This value is called the critical value. And then we can get this from the calculator and then compare with the z-statistic. If the value lies on what's called the critical region, then we reject 80. So this area in green is called the rejection area, while the other area, the big area, is called the acceptance region. So when we do the test, the calculator gives the value, gives the p-value and also the z-statistic. So I'm going to show to you how to find the critical value, how to find the z-statistic. The critical value on Texas calculator, you go to distribution, and then you use inverse normal. We want to know an area of 0.005 with mean zero standard deviation 1, tail left. When you do this, you're going to find the value to be minus 1.64 to 3 significant figures. So that's our critical value, minus 1.64. Now, suppose we perform the test again, the test that has been performed previously. I'm going to repeat this test, go into statistics, tests, and then z-test. This time, statistics, the first test, it has a mean of 100, 1.6, the sample mean 99.4, and the sample size 40. This is according to the information of this problem. Now, the calculator is going to give us again the p-value, but also the z-statistics. The z-statistics is here, minus 237. Minus 237 is a value which is much smaller than minus 1.64. Suppose, let's say it's here, minus 2.37. So this value is called the z-statistics. This value, if it lies on the critical region, then we have to reject the 80. So in this case, the decision rule is different. Since minus 2.37, the z-statistic is smaller than minus 1.64, the critical value, then we have enough evidence to reject H0. This value in Casio calculator can be found using the following process. You go here to the menu distribution. At first, you set mean standard deviation to 0 and 1, mean 0, standard deviation 1, and then you choose any value for x, such as, let's say, 0.20, and then you execute, and then you just go here to the area to select 0.05. Then we get the same value, again, minus 1.64. Clearly, in this case, we have to use this tail, x is less than or equal to, and then insert the value 0.05. And so that's another way of taking a decision on the statistical test, okay?